Hello, today we are going to be talking about exponential form, logarithmic form, and how to evaluate logs. So we do have a few definitions that we got to talk about. The first one is a logarithm. Logarithm is abbreviated as LOG on your calculator. So if you've ever noticed the LOG button, that stands for a log. In a log, basically, its basic definition is a positive number y to the base of b. Then we have some what we call common logs, which common logs are the ones you can use with your calculator. So it says can only use the log key when the base is 10. And that's what we call a common log, as it says in the definition that it's a log with a base of 10. So that's the only time you can use the log button on your calculator. And then a natural log is the abbreviated as ln. So if you've ever noticed the ln button on your calculator, then there you go. And that one, the base is not going to be a number. The base is actually going to be the letter E. Okay. And most of you know like pi stands for 3.14. Well, E actually has a number equivalent as well. But we're just going to use the button on our calculator so you don't have to worry about memorizing it. So the first part of our lesson is going to be going back and forth between I give you exponential form, you write it in log form. I give you log form, you write it in exponential form. So let's talk about what each one of those forms looks like. Exponential is always y equals b raised to the x. Logarithmic form is log base b, which is a little bitty number below the log of y equals x. So my first table here, I give you exponential form, and you're going to notice this exponential form is written backwards. So this one looks like b raised to the x equals y. So b is 5, x is 4, and y is 625. So now when I go to plug that into my log form, I'm going to say log. B we said was 5. Y we said was 625 equals x, which we said was 4. Okay, next one. I give this to you in log form. So if I write log form underneath that, that's log b y equals x. So b is 3, y is 9, and x is 2. So now if I write that back into the form y equals b raised to the x for exponential, that would be 9 equals 3 raised to the second. Okay. Why don't you pause the video and try the third and fourth one by yourself, and then we'll do the fifth one together. All right, so then let's talk about the last one. So just to make sure you're on the right track on the last one, b is going to be 7. X is going to actually be x plus 2. And then y is going to be 9. So log base b, which is the number 7, of y, which is 9, equals x, which happens to be x plus 2. So hopefully everybody's okay with writing them back and forth. This will come into play in other sections in this chapter as well. So make sure you let me know if you had any questions on that. The next thing we're going to talk about is how to evaluate logs. And to evaluate logs, we're going to use what we call the change of base formula. And here's the change of base formula. Log base b of m equals log m over log b. Now, why do we use the change of base formula? That is so we can use the calculator. Okay, because the log base change of base formula changes the base into 10 so that we are allowed to use the calculators. Okay, so my B is 7 and my M is 2,401. So change of base formula, log of 2,401 over log of 7. So go type that into your calculator. And when you type into the calculator, sometimes they're going to come out to be nice, neat answers, and sometimes they're going to be decimals. Okay, so if you have any questions about typing in your calculator, make sure that you let me know. But when I type this in, you do have to make sure that you close the parentheses, especially on the top. It gets a little picky if you don't close the parentheses. But I came up with a nice, neat number of 4. So the next one, log m, which is 125 over log 1/5. And then just once again, when you type in your calculator, make sure you close your parentheses. And when I typed this in, I got -3. The next problem is a little unique because on this one, you're going to notice it doesn't have a little bitty base number. If it doesn't have a little bitty base number, then that means the base number is always 10. So if no base number, then the base is 10. So if the base is 10, you don't even have to use a change of base formula. You can just literally hit the log button on your calculator and then type in 24 equals, and you get a decimal, which is 1.38 when I round it. Now, if you forget that, you could just hit the log button. You could also do the change of base formula. You just have to remember that the base number is 10. And if you do that, it will still give you the same answer as above. Okay, then we have a special case here on D. So let's look at the special case. For this one, it would be log of 5 over log of 5. And then you're going to notice, hey, these are the top and the bottom are exactly the same. So they're going to cancel out and give me 1. Just like in the past, you know, if you had 2 over 2, you'd say, oh, 2 over 2 reduces down to 1. So that's the same philosophy as what we do here. So if your base number and your number right next to it are exactly the same, they are going to cancel out for 1 because 1 would be the little exponent that our 5 has. Okay, last one. This one, instead of log, we have ln. And for ln, you do not have to do change of base. So no, sorry, that does not look like the word no. Let me try again. No change of base. On this one, you get to use your calculator. So use calculator and search for your ln button and type in your ln button and then hit 20. And I got about 2.995, which I'm going to round it to 3. Done.